Okay, what I'm doing here is finding or graphing a function and its inverse. And I've already started the process here. This one is a line. It hits at y-intercept of 6 and then has a slope of 1 down and 3 over. So you can see that I've generated all of these points along here. And I need to now, let me darken that line a little bit. Once I get that drawn, I'm going to do the inverse by simply reversing the x and y's on each of these points. Now, one way to do this is to simply switch colors. So I'm going on this one, use a red pen for the inverse. Okay, so let me give you a few of these points here. This one over here is at 9, 3, so I'm going to go 3, 9. And if I back up, this one's at 6, 4, so now I'm going to go 4, 6. And then this one here is at, looks like 3, 5, so the inverse will have 5, 3. You just switch the x and the y values, and you can see it's coming through this way already. 0, 5 becomes 5, 0. Oops. Okay. Oh, that's 0, 6, so it's 6, 0. Never mind the dot over here, it's this one. Alright, so negative 3, 6, negative 3, 7 becomes 7, negative 3. Yeah, that looks like it's right on track. And so forth. We're going to get these dots here if we reverse the other ones. And here's our inverse. So you graph the first one and just reverse the x and y values on each point. Okay, so here's another one, and this I got graphed by just using my graphing calculator. Let me show you what I typed in. There's the equation, and you can go to the table of values and plot points there, or you can hit graph and then use the trace key. I'm going to start with 4. Well, first of all, I kind of find this place. It looks like it's around 4 there at the bottom, so I'm going to hit 4 enter to find my vertex, and then go 5, 6, and 7 to get those points. And if I want to go backwards, I'll go 3, 2, and 1 to get those points. Okay? Now, once I have the first one graphed, I just reverse the coordinates to find the points on the other one. Now I'm going to, instead of switching colors to a red one, I'm going to use this blue ink again. And what I'm going to do in that case is when I reverse it, I'll put the dot over here, but I'll put a halo around it. Okay, hang on, there's an announcement.
Mrs. Ahrens, please call the office. Mrs. Ahrens, please call the office.
Well, I hope that was Mrs. Ahrens calling the office. Anyway, here we go. So I'm going to start with the vertex. This vertex is at 4, negative 5, so over here it'll be negative 5, 4. And put a little halo around it so you keep track of the fact that that one is on the other graph. And I'm going to do this wing here. So 5, negative 4 goes negative 4, 5. And then looks like 6, negative 1. I'm going to go negative 1, 6. And then finally 7, 4 becomes 4, 7. And there's one of the wings of the other one. You got to keep circling this or doing something or changing colors of ink. Now the other direction I got 3, negative 4, so I want to go negative 4, 3. And then it's 2, negative 1, negative 1, 2. You just switch x and y. And 1, 4 becomes 4, 1. And now here's our other graph. And you can see that the original, they reflect over this diagonal line that I've drawn here. That's the axis of symmetry. It's just simply y equals x, or 1x plus 0 if you prefer it written that way. Okay, so the next section we have to come up with our own inverse, and then it tells us we have to find the domain and range, and then decide whether it's a function. So the first and last of the instructions we did earlier on the previous video. Range. Okay, so switch the x and y and solve for y. Now, since every x you plug in here, it generates just one y value, this is a function. And now we're going to turn our attention to finding the domain of the original and its range, and the domain of the inverse and its range. Now you're going to find the domain of the original by graphing it, and then you'll use it to find the range of the other one. And I did that switch on purpose. When the x and y trade places right here, it means the side to side governs the up and down of this one. So here we go. Graph the first one, 2x plus 6. Zoom 6. And you can quickly see that this line stretches forever in both directions, right and left. So all real numbers. That means when you flip it around, the up and down will stretch forever up and down. So these are partners. And now I'm going to do the range of this same picture. This line goes up and down forever with no breaks. So it has a range of all real numbers. The y values go up and down forever. And that means when you flip this, the x values will do the same thing, go forever right and left. So that was a pretty easy one. Now when I get over here, it's going to get a little more interesting on the domain and range part. Okay, so let me write this with the x and y switched. Okay, the lowest priority over here is at adding 4. We'll fix that first. Now, parentheses is done before anything else, squaring comes next, and multiplying comes last. It's this multiplying that you have to fix next. Solving reverses PEMDAS. Okay, now we have to do the square root to get rid of that, and I would normally do that. Normally that'd be a higher priority, but the parentheses says that minus is the highest priority, so I have to pick off the least priority. And I'll put my plus and minus on here. And finally I'm going to bring this 4 over and plop it in front of the plus and minus sign. While I'm doing that, I'm going to turn this around. Okay, with the plus or minus sign, it's not a function. Every x value. I should have put a little article in there, not a function. And the plus or minus sign generates 2 answers for every input, so you're not going to get, it's not a function when it does that. Okay, D and R for the original, and down here the inverse. And the proper way to do this is to graph the original. So give me a second, I'm going to wipe out the old equation I had on there. Type in 3 times x minus 2 squared plus 4. And I'm going to see what this graph looks like. So actually, let me just hit zoom 6. Here's what I wanted to do. Try that again. Okay, so we get a parabola that stretches forever right and left. So the domain is all real numbers, which makes the range down here all real numbers. Remember, those are partners. But this parabola does not stretch forever up and down. It has y values that go from whatever this y value is upwards. So I'm going to hit the trace key and see if I can find that. It looks like a y value of around 4, but I want to make sure. So I'm going to go second calc choice 3 and find the minimum height there. And you saw me use a left and right bound there. 4 is the value that at that spot. So y, the y above or equal to 4, which when I come down here I have to switch the x and y. So x's are above, or I mean to the right, or equal to 4. So the graph of the inverse would turn this way and it would stay to the right of 4. Okay, so that's it for problems 9 through 16.